Alright, stats, welcome to Yak Math Videos for your first video of 2018. Today we're going to continue on with your notes from yesterday. We're going to do a few practice problems in your Chapter 13 practice problem set. Alright, then on Monday I'm going to give you your first homework sets. It's really not that long compared to what you're going to get the rest of the semester, so your first homework set will be due on Friday. You'll get that on Monday, and we'll go from there. All right? Anyway, I want to thank 2018's first mega sponsors. We have Cliff Bar, Laura Bar, Garmin, Fitbit, Quality Coffee, Chinatown, Ruby Tuesday, Starbucks, and Tazo Tea. Again, email the program if you want to be another sweet premium mega sponsor. Folks, the last things you should have written down yesterday was this. A combination, that binomial coefficient n choose k is equal to n factorial divided by k factorial times n minus k factorial. Again, what a factorial is, folks, just in case you forgot, let's say we had a 4 factorial. 4 factorial would be 4 times 3 times 2 times 1. All right, so it's the product of all the numbers up until that number, starting with 1, all the whole numbers there, the counting numbers, I'll say. All right, but folks, we are going to use your calculadora for that. So folks, let's write this down. Again, these are your notes, so pause this, or pause this like right now, take your time. Example 1 says, in how many ways can you make 8 free throws out of 10 free throws attempts? So you want to make, you're shooting 10 free throws in a game, you want to make 8 of them. All right, that is 10 total shots, n is 10, and you would be successful in k of them. 10 choose 8. Now if I were doing this by hand, 10 choose 8 is equal to 10 factorial divided by 8 factorial times 10 minus 8 factorial. Well, 10 minus 8 is just simply 2 factorial. It's basically how many observations, factorial, over how many successful attempts, factorial, times how many unsuccessful attempts, factorial. This is how you would do it if you had to do it by hand, folks. Instead of writing 10 times 9 times 8 times 7 and so forth, you would do 10 times 9 times 8 factorial, because 8 times 6 times 5 times ... 1 is the same thing as 8 factorial. Those would cancel out. You'd have 10 times 9. 2 factorial is simply 2 times 1, which is 2. Folks, we don't need to do that because we can use our calc. We can hit the math button. Let's try to do that right now. So everyone have your calculadora. You know you need that. Let's bring it over here, some better lighting. All right, so what we're going to do is we're going to hit the math button right here, the math button. And when we hit the math button, folks, we're going to go all the way over to PRB, probability. All right, so let's scroll over. Okay, now you're going to see I made a slight boo-boo. We're going to hit number 3, but before we do that, so I'm going to go back out. If you're ready to type in 10 choose 8s, what you need to do first is you need to put the number that, of our observation. So I need to put in 10 first. All right, so we're going to try that again. I'm going to type in 10, because that's what I'm choosing from, 10. Then I hit math. I go all the way over to PRB, and I'm going down to 3. So it says 10 NCR, R is in place for K here. All right, so because I typed in 10 first, that's telling the calculator that 10 is my N, and again, in this case, R is the same thing as K. I want 8s. I want to be successful on 8 of them. And then I hit enter, and look at that, I get 45. So let's say I wanted like 20 choose 17. All right, I would hit 20. I would hit the math button. Go over to PRB. Go down to 3. And then hit 17. Enter. Boom. I can get any of those combinations. Okay, so we want to start using that forward, or going forward, all right? We want to start using that going forward. And folks, the next thing then you need to write down, in order to do these problems, we need to know what the binomial probability distribution looks like. So write this down, binomial probability. Again, take your time, pause this whenever you need to. If x has the binomial, wish I could get this all here in one shot. If x has the binomial distribution with n observations and probability p of success on each observation, you can pause this whenever you need to. The possible values of x are 0, 1, 2, up to n. Again, you can be successful 0 times, 1 time, 2 times, 3 times, or all n of them. If k is any one of these values, all right, then the probability that x is equal to k, x is equal to k, is this. That is the binomial probability distribution right there. It is n choose k, that's the binomial coefficient. P is the probability of success, could be 0.8. K is how many times it would be successful. 1 minus P is simply the probability of failure, all right? If I have an 80% chance of being successful, I have a 20% chance of failing. And then N minus K is simply how many times in that problem do we want to be unsuccessful. Here's a layman's term to write it, all right? Anyway, highlight this, folks. This is key right there. That is the sweet, sweet binomial probability distribution. All right, again, pause this whenever you need to. You might have to go back because I want to get through these examples and then a few in your actual practice problem set. So write these down. All right, in how many ways, we already did that example. Let's do this one. Okay, so like yesterday, I think we did one like this yesterday when we were shooting 5 out of 4 attempts. You are an 80% free throw shooter. What is the probability you make exactly 8 out of 10 free throws? So the things you need to write down, probability is 0.8. N equals 10, and you have to define x. X is made free throws, made free throw, all right? I want to know the probability that x is exactly 8. So yes, in your homework, when you get it on Monday, you have to write those things out. I want to know what is the probability x is exactly 8. All right, so here's how I write it using that above formula, again, which you just wrote down. This is n, choose k. There's 10 observations. I want to be successful on 8 of them. Now, we just did that one up above, but again, you would use your calc for any one that you didn't know. My probability of success is 0.8. I want to be successful 8 times. My probability of failure is 0.2. I want to fail 2 times there. Here's what I would recommend on these problems, folks. I would always, again, go to your calculator, find the combination part first. Now, we've already done, I would do 10, choose 8, and then write down what I get, 45. And then in your calculator, you can do the next part, on your own, or by itself altogether. You can do 0.8 to the 8th power, all right, times, again, you can use parentheses, 0.2 to the 2nd power, all right, and then multiply it by that binomial coefficient 45, and there you go, rounded to 3 decimal places, 0.302. So basically a 30% chance that you make exactly 8 out of 10. That's pretty high because that's just one exact. You want to make exactly 8 out of 10, all right? Now in example 3, it's the same question as above, but you want to make at least 8 out of 10, all right? You have a lot of these questions in your homework. If I want to make at least, that means greater than or equal to 8. I want x to be greater than or equal to 8. That's the probability x equals 8 plus the probability x equals 9 plus the probability x equals 10. Okay? That's the quickest way to do it. You don't want to do 1 minus the probability of 7 or below. That's too much work. Here's what we should do, folks. First off, you already know the probability of making exactly 8, so just rewrite it. Plus, if I want to be successful 9 times, then of the 10, I want 9 to be successful. Probability of success, 0.8, I want to be successful 9 times. Probability of failure, 0.2, I want to fail 1 time. Then plus, now here's a little cool thing, folks. If I want to be successful 10 times, then that means I just want to make every single shot. So I don't really need to write all this out. I can just write the probability of success raised to the 10th power. Because 10 choose 10 is going to be 1. And any number to the 0 power is 1. All right, so we learned that from pre-algebra. So I can just simply type in 0.8 to the 10th power, and I get that. Now, what's on this one next here that'll help you out? You guys will learn anytime you have n, choose n minus 1, it's always going to be n. But, again, we'll type that in. I'll show you how I would do that, how I'd use my calc to do that. So first off, I want to do 10, choose 9. I know it's a little fuzzy here. Quality's not great right here. The line's not fantastic. 10, math, go down here. 10, choose 9, simply 10. Then I would multiply it by 0.8 to the 9th power. And then I would multiply that by 0.2. All right, there we go. 0.268, which is what we get. Add them all up. Probability that this player makes at least 8 out of 10 free throws, if he's an 80% free throw shooter, is over 2/3. All right, there we go. So now, folks, what I want you to do, this is probably going to have to be a 2-part video here. I'm already at 11.5 minutes, I believe. What you picked up today, your chapter 13 practice problem set here. We're going to start using this a bunch. Again, I said those packets were still coming. This is going to be very beneficial for your homework, and I believe I did several of these with you. So let's take a look. A surgical technique is performed on 12 patients. Again, this is the binomial probability distribution. There's the formula right there. Okay, just as we wrote down before, so highlight that. That's what we're using. Okay, so a surgical technique is performed on 12 patients. You are told there's an 87% chance of success. Find the probability that the surgery is successful on at least 9 of the 12 patients. This one takes a little bit of time. So define X. X is a successful surgery. My N is 12. That's how many observations I have, 12 patients. My probability of success is 0.87. I want to know what's the probability that X is greater than or equal to 9. That's the probability X is 9, plus the probability X is 10, plus the probability X is 11, plus the probability X is 12. All right, so case by case here, 12 choose 9. 12 choose 9 is, oh, I forgot to get these answers here. So what we're going to do is now would be a good time to pause this video, and in video number 2, which you already have at your disposal, we will have those answers.